So now we can start.
Okay.
Namtu ma'am, I have started.
Yeah, let students also join. If students are joining, sir.
See, students are joining, and I think around 70, 80 students are in one classroom where they will, attend it directly online over there. So it's a common online facility over there for them. So they may not be
Okay.
visible over here.
Okay.
Okay.
They will be joining after some time, right?
No, they are joining. The live session is already there in the classroom. So they are attending in classroom directly.
Oh, so I can start now?
Yeah, just
Namrata ma'am.
let me welcome you, sir, officially. Good morning, everyone, and welcome to Industrial University Cloud. I, Namrata Bajaj, on behalf of Industrial University, welcome Dr. Mitra, who is IIT
I can
Guwahati
hear Dr.
as-
Vias, but I cannot hear Dr. Bajaj's voice actually.
Is it audible to others?
Now it is little bit audible. Yeah.
Yes,
Okay,
yes.
okay. Yeah.
Keep microphone like this.
Yes, sir. I welcome Dr. Mitra, who is from IIT Guwahati, and he is associate professor in CSE department. The human intelligence is these days fascinated with artificial intelligence. So we have kept this very topic, wherein everyone can learn the basics of artificial intelligence and machine learning, and for which we have invited Dr. Mitra. We are very happy that the MOU signed between Industrial University and IIT Guwahati is going to have its first debut webinar with Dr. Mitra. I welcome Dr. AP Vyas, who is Dean School of Engineering. I also welcome Dr. Sumit Chaudhary, who heads Computer Science Engineering Department at IU, and Dr. Sidheswar. We were expecting our provost, Dr. Yadav, and other panelist members to join, but the technical glitches have actually refrained to join. So we will start with the introduction of Dr. Mitra, which is imperative for us. And Dr. Mitra will have your introduction first, and then we will give you the podium, or maybe the spotlight for you to continue. So over to Dr. Sidheswar Routray for introduction of Dr. Mitra.
Thank you, ma'am. Am I audible?
Yes.
Yes.
Good morning, all of you. Respected Dr. Pinaki Mitra sir, the speaker of the today's event, Dr. Amish Spekaer sir, Dean School of Engineering, Registrar Industrial University, Dr. Sumit Chaudhary, HOD Computer Science Engineering Department, Dr. Namrata Bajaj ma'am, HOD Humanities and Basic Science. It is a privilege to introduce the speaker of the event, Dr. Pinaki Mitra sir. Thank you, sir, for accepting my request and agreeing to deliver a lecture on the popular topic of AI and ML. Currently, Dr. Pinaki Mitra sir is working as an associate professor in the Department of Computer Science Engineering, IIT Guwahati. He was a former postdoctoral fellow at Carleton University, Canada. He has completed his PhD in computer science from Simon Fraser University, Canada in '94. He was also awarded SFU President's PhD research stipend. He has completed his master's from the prestigious Indian Institute of Science in 1989. He has completed his bachelor's in computer science from Jadavpur University in '87. Sir is having huge experience. His research interests are artificial intelligence, machine learning, data mining, computational geometry, optimization, and other areas also. He has published a number of papers in reputed journals and top conferences, such as IEEE Transaction on Computational Social Systems, Frontiers of Computer Science, Multimedia Tools and Applications, Microprocessor and Microsystems, and many more. Also, SAR has completed the Microsoft Research India RX Lab program. Sir has guided many masters and PhD scholars. So definitely the participants will get benefits from his expertise on the topic. Thank you, sir. Also, I would like to say, since recently Indrasil University has signed a MOU with IIT Guwahati for research and academic collaboration. Dr. Pinaki Mitra sir is representing CSE department of IIT Guwahati to take the MOU further. I got the opportunity to represent the CSE department of Indrasil University to take the MOU further. So, sir, I need your help and support so that in future we have research and academic collaborations like the Department of Computer Science with the Department of Computer Science of Indrasil University. Thank you, sir. We are waiting to hear you on the popular topic of AI and ML. Thank you, sir. I hand it over to Dr. Namrata Bajaj.
Thank you, Routray sir. The credential seems to be very, very impressive. And now, without much delay, we would like to hear from Dr. Mitra. Over to you, sir, and the entire spotlight is yours.
Okay. So I will share my screen, okay? And I'll start the presentation.
Right, sir.
So the title of my talk is Artificial Intelligence and Machine Learning. And I am Pinaki Mitra. I am in the Department of Computer Science and Engineering of IIT Guwahati. So nowadays the very popular combination is AI, ML, and DL. AI stands for Artificial Intelligence, ML stands for Machine Learning, and DL stands for Deep Learning.
Sir, okay. Sorry to interrupt you. We are yet to see the screen, sir.
You cannot share, you cannot see the screen?
No, not yet, sir.
Yeah, screen is visible.
You can see, Mama, like I can see the screen.
Okay. Now it's visible, sir.
Can you
yes.
see?
Yes, sir. Yes, sir. It is visible now.
Okay.
Yeah, thank you.
So first question comes when you talk about artificial intelligence, what is intelligence? So there is a very popular test known as Turing's test, in which there is an interrogator. Okay, there are 3 rooms. In one room, there is an interrogator. In one room, there is a computer. And in one room, there is a human being. Okay, the task of the interrogator is to distinguish between which one is the computer and which one is the human being. Okay, so what the interrogator will do, interrogator will ask some questions. Okay, and on the basis of the answers, the interrogator has to distinguish between the computer and the human being. Okay, so human interrogator has to differentiate between computer and human by asking some questions. So what sort of questions you can ask? So, so in the Turing test, the human interrogator may give 2 large numbers to multiply, okay, to both to computer and to the human being who is sitting in the other room, other 2 rooms. Okay, so multiply, they can give 2 large numbers to multiply. Now, if the numbers are very large, typically, the human being will take time to find the product of those 2 numbers, but the computer will give the answer very fast. So if the computer immediately gives the answer, the human being can easily figure out which one is the interrogator can easily figure out which one is the human and which one is the computer, because the computer is expected to give the answer very fast, right? So if the reply is quick and correct, the interrogator can easily distinguish between the computer and the human. Okay. But so an intelligent computer would defer its answer for some time and probably give a wrong result. Okay. So in that case, it will be very difficult for the interrogator to figure out which one is the computer and which one is the human being, because you don't expect a computer to come up with a wrong result after quite some time, right? So this will definitely befool the interrogator. Now, in artificial intelligence, we use a type of function which is very important called heuristic function. What is this heuristic function? These are functions that are evaluated by computers to guide the search process in an efficient manner. Okay. So search that uses heuristic function is called heuristic search. Okay. And in many real world problems that can be modeled as state space search graph that include computer scheme, we encountered the problem what we call combinatorial explosion. Okay. So we have to handle this problem of combinatorial explosion in the state space search. So heuristic search is frequently employed in such problems to facilitate the decision-making process in an efficient way. Okay. So now a typical example we'll see in the context of a very common game called 8 puzzle. In practice, we encountered a bigger version of this called 15 puzzle. We usually have some tiles, okay, and these tiles are numbered from 1 to, suppose in 8 puzzle they are numbered from 1 to 8, and in 15 puzzle they are numbered from 1 to 15. Okay. And in the 8 puzzle, there are, you can see it's a 3x3 board, and there will be one blank tile. Okay. And there will be an initial position and there will be a goal position. Okay. So the computer has to figure out the sequence of moves that will take this initial position to the goal position. This is what is this 8 puzzle game all about. Okay. So since I told about this heuristic function, a simple heuristic function will be the number of misplaced tiles. Okay. So here you can see that 5 is placed in the proper position in this. 4 is in the initial position, 5 and 4. 5, 4, 3 all are placed in the right position. But 1 and 7 is also in the right position. Okay. 1, 2, 8, 6, they are not in the proper position. Okay. So if I use this heuristic function, which is the number of misplaced tiles. Okay. So with this, so if I include the score for the blank tile also, as I told, 4 tiles which are numbered, and the blank tile is also misplaced. So there are 5 tiles which are misplaced in the initial position. Okay. If you take a look at the previous slide, 5 tiles, this blank tile is also not in the proper position. So 5 tiles are out of position. So that is the score for the initial position, including the blank tile. Okay. So better, so I can, so my goal will be to give a move that will minimize the number of misplaced tiles. Okay. So this is one heuristic. A better heuristic will be the sum of Manhattan distance of each tile from the current position to the goal position. Okay. If it is not misplaced, this Manhattan distance will be 0. Otherwise, it will be greater than 0. Okay. So this, in fact, you can show that divides the search space into 2 equivalence classes. In this actually game of 15 puzzle or 8 puzzle, actually, from every state you cannot reach to any other state. Actually, the entire search space is partitioned into two connected components actually. In one connector, if they are both in a start and goal state are in the same connected component, you can reach from the initial to the goal. But if the start is in one connected component and the goal is in another connected component, then they are not reachable. It may happen like that in this game. Okay, so with this heuristic score, the initial position will be 6 with this Manhattan score. Okay, that is including the blank tile. And in the heuristic search, we will evaluate each state that can be reached by a feasible move from the current position, and we'll expand the corresponding next state that has the least value of HN. So from the current position, the blank tile can be moved to, if you consider the position of the blank tile, depending on that, you can have either 4 moves. If it is the blank tile is in the center, you can have 3 moves if it is on the edge, not in any of the 4 corners. And if it is in the corner, you can have 2 moves. Okay, so I can have multiple moves from a current state. Now, which move I will take, that will be guided by this heuristic function. I will take a move that minimizes the value of this heuristic function on the next state. Okay, so sometimes we also add the distance of the current position from the initial position. Okay, so and add it to the heuristic function value to obtain the final evaluation function. This is typically applied in a type of search called A-star search, A-star algorithm. Okay, so the distance from the initial position to the next move and from next state to the goal position, the sum of these two are counted. This sum is, the algorithm tries to minimize this sum. Okay, so Fn is equal to Gn plus Hn. Gn is the distance from the start position to the current position, and Hn is the heuristic function value of that state. Okay, so different state space search techniques are there, and these are the possible state space search techniques: breadth first search, BFS, DFS, that is depth first search, best first search, okay, A star, and AO star. Okay, so these are different state space search techniques. Okay, so these search techniques are further accelerated by there are techniques called alpha beta pruning. Okay, so alpha beta pruning is applied in the context of min-max search when it is a 2-player game. So there are 2 types of in this 2-player game, like tic-tac-toe or chess or whatever. So this you have a maximizing level and a minimizing level. Okay, so when one player tries to maximize the value of the heuristic function, the other players try to minimize the value of the heuristic function. And this alpha beta pruning is applied, one to the maximizing level, another to the minimizing level. Okay, so this hugely reduces the state space search tree. Okay, it means you need not expand all the branches of the state space search tree, and you can prune a lot of information. Okay, and make the state space search much more efficient by a technique called alpha beta pruning. There are other approaches also, like bidirectional search. Instead of searching from the start, you can start also from the goal and proceed from both the directions. Iterative deepening. Okay, instead of making one move from the current position, okay, and use the value of the heuristic function, make multiple moves, multiple level moves. Okay, and then try to find the value of the heuristic function based on, like, if you try to you can do means k deep search, means k level depth. That k parameter you can vary, right? So these search techniques can be incorporated in games like tic-tac-toe, chess. So tic-tac-toe is a simple game, chess is a much more complicated game, but these techniques are employed. Okay, and they are successfully employed to make this game. Means there are to make very good these softwares for this type of games. Okay, So next we'll see different categories of learning. So learning can be classified in different ways. One possible classification is inductive learning. Here functions are learned, functions learned a hypothesis about some underlying and unknown functions. Typically, these artificial neural networks is an example of inductive learning. Okay, deductive learning. This learning enhances system performance by deducing additional rules from the given facts. Okay, so this so learning decisions, functions, grammars, and other rules can be classified in another way. Okay, supervised learning. Okay, so this is it is accomplished by presenting training examples to a learning unit. Okay, so in supervised learning, what you have is basically usually have class level data. Okay, so and you can apply the supervised learning techniques. First, you train the data, and then you perform the testing operation. And unsupervised learning, their labeled training examples are not available. So data are not class level data. So in such cases, data set has to be partitioned into some classes that have some common features. This form is called clustering. Okay, so you have to find out the set of clusters. Okay, so that is the goal of this unsupervised learning. Okay, so now different machine learning classifiers. So in unsupervised classifiers are k-means. Okay, outlier detection. Outlier means basically noise. Given a set of data, you have to find out the noise, and particularly if you are doing it incrementally, you have no way to figure out whether it's whether the data is an outlier. I mean, so you cannot, no way you can label the data. Okay, so outlier detection definitely falls in the category of unsupervised learning. Okay, and association rule mining. This is typically applied in market basket data, means where you have to find out the patterns, association rules in transactions. Okay, so you have a set of transactions. From there, you have to find out the association rules. Okay, so this is the typical data mining problem. Okay, so this association rule mining is also classified in the category of unsupervised learning. Okay, and in the supervised learning, you have artificial neural networks. Okay, which started with the work of Mervyn Minsky when he started the notion of perceptron. Okay, in which he tried to separate out two linearly separable classes. Okay, with a hyperplane. Okay, so that perceptron tries to find out the separating hyperplane. Okay. Okay, and then there are subsequent improvements. Okay, in which you had feed forward networks, you have optical networks and other networks. A lot of other networks came in. Okay, so the basic goal is basically you have to adjust the weights in different neurons. Okay, applying basically the minimization method. Okay, so first so that the difference of the output and input, okay, desired output and the actual output is minimized. Okay, it is possible if you this type of the thing is possible if you have class level data. You have support vector machines. Okay, and where you have the notion of these kernel functions and all. And you have k nearest neighbor classifiers. So these are all examples of supervised machine learning classifiers. Okay. You have now the performance metric. For supervised learning, the performance metric is a bit easier. Life is much easier to evaluate the performance of these different classifiers. Okay, because you have the class level data. So you know when in the test phase, okay, in the test phase, sorry, in the training phase, when you have done the training at that time, from the output, you can figure out whether the output which is coming is matching with the actual level. If it is not matching, it's a false positive. If it is so you have the notion of what we call true positive, when actually you are getting the correct output. True negative, when the label, suppose you have if the labeled is true, but you are coming out with the it is reporting it is belonging to the other class. False positive, okay. So means so it is belonging to class 2, but it is, you are getting it is it is belonging to class 2, but you are getting the result of class 1. And false negative, okay. So this different types of classification you can only perform, okay, when you have class level data and you have different performance metrics like precision, which is true positive divided by true positive plus false positive, and recall, which is true positive divided by true positive plus false negative. And other performance metrics are also there, like F1 score and all. So you have different performance metrics for this type of supervised learning, okay. But for learning, it's a little bit more complicated. You have a notion called the performance metric. There is a notion RAND index, okay. So you don't know which class the data belongs, okay. So the RAND index measures the performance in this way. So you have a set S, okay, which comprises of, suppose, these objects O1, O2 up to N, and you have performed 2 clusterings. You have 2 clusters. You are trying to compare 2 clustering algorithms. One clustering algorithm has created X1, X2, XR clusters, and the union of these clusters is basically I am denoting it by X, and another has created S clusters, Y1, Y2 up to YS. Okay, so I want to compare the performance of these 2 clustering methods. Okay, so in this case, so the performance can be compared. Suppose you have O1, you have taken a pair O1, suppose O1, O2. It may happen that O1, O2 belong to the same set Xi in X, okay, and also the same set Yj, same cluster Yj in Y. So that so number of such pairs, we count it as A. So A is the number of pair of elements that are in the same subset of X and in the same subset of 1. Okay. B is, suppose O1, O2 belongs to different clusters in R, in X, and similarly different clusters in Y. So B is the number of pairs of elements that are in different subset in X and different subset in Y. Similarly, C is so C is a little bit different. C is the number of pair of elements that are in the same set Xi, same subset Xi in X, but in different subsets, different clusters, Yj and Yk in Y. Okay, so C is the number of such pairs, and D is the number of pairs that are in 2 different clusters in X, Xi and Xj, but in the same cluster in Y, Yk. Okay, so I have so A plus B plus C plus D is the number of all such pairs, that is n choose 2. Okay, so the RAND index is basically A plus B divided by A plus B plus C plus D. So as I told, A plus B plus C plus D is all such pairs, that is n choose 2. So RAND index is A plus B divided by n choose 2. Okay, so this is the performance metric that we can apply for unsupervised clustering. So this is a bit more, it's not that straightforward performance metric like supervised clustering, okay, but you have something with which you can measure the performance of this clustering methods. Okay, there are deep learning techniques. So here we have heard that, so in these artificial neural networks and all, you have to extract the features, okay, before, and so in these deep learning techniques, we have heard the problem of feature extraction as we had to do for artificial neural networks. Okay, and the networks that are commonly used for this category of problems are CNN, convolutional neural networks, GAN, that is generative adversarial networks, and this is classified as semi-supervised learning. Okay, so so this there are other networks also like RNN or all actually for transfer learning and all. There are different other networks. So I mentioned only few. Okay, so these are some networks that are used in deep learning. Next, we will see there are inductive learning. Okay, so inductive learning, for inductive learning, follow-up programs are based on inductive learning of horn clauses. Okay, so in inductive learning, our goal is to learn a program pi consisting of horn clauses. Okay, row, each of which is of the form. Okay, row going to row is this is the rule actually. So row implying alpha 1, alpha 2, alpha I. Okay, so alpha is of the atomic formulas that unify with ground atomic facts. Okay, and the idea is that pi should evaluate to true when its variables are bound to some set of values known to be in the relation we are trying to learn. Okay, so these are positive instances of training set, and pi should evaluate to false when the variables are bound to some so when the it should be the it should be are not bound to some set of values known to be in the relation sorry, are bound to set of values not known to be in the relation we are trying to learn. So this is so these are negative instances, okay, of the training set. So we have the positive instances of the training set and we have negative instances of the training set. Okay, so and so in inductive learning, the ground atomic facts with which alpha are to unify are said to constitute the background knowledge. Okay, so there is notion of unification. Okay, so that's so, and they are usually provided as subsidiary prologue programs which can be run and evaluated in the form of a list of facts. Okay, so you have in prologue you have fact base and rule base. Okay, so so prologue programs that can be run and evaluated in the form of a list of facts. Okay, so this is a typical example of deductive learning where you are using resolution and refutation. Okay, the idea here in resolution is basically negate the thing which you are trying to derive. Okay, and try to resort to new. Okay, now this process of resolution is basically undecided, but there are several strategies, heuristic strategies that try to perform this resolution process. Okay, so this is a typical example of resolution. Okay, so suppose I have it is like I'm trying to derive pushable A. Okay, so this would unify to this. These are in the other set. This is the general knowledge. So we have not of heavy X or not pushable X, not of green X or heavy X. Okay, so this will unify with this. This clause contains pushable. So pushable and not pushable would cancel out, but X will be substituted by A. So we have not of heavy A. Now not of heavy A will now unify with not of green X or heavy X. So not of heavy A and heavy A would cancel out, and X will be substituted by A, and we will have not of green A. And this green A is a specific fact. They will resolve to X and X complement resolve to nil. So here these two will resolve to nil. So this is a typical example of resolution of clauses. Okay, so here the rules are green implies heavy X. Okay, heavy X implies not of pushable X. So A implies B is nothing but not of A or B. So that's how I wrote in that box. In the previous set, you will see this not of heavy and not of pushable. So rule says green implies heavy. Okay, so green or not of heavy. Okay, so if you take a look at the previous, not A or B, sorry. Oh, sorry. Yeah, not green or heavy. Yeah, not green or heavy, right. So not of A or B. So green implies heavy X, that is not of green or heavy. Heavy X implies not pushable X. So not of heavy X or not of pushable X. Facts are green A. And so from the transitivity of implications, okay. So if you can clearly see that green implies heavy, heavy implies not a pushable, so green implies not a pushable. Okay, and in the resolution based system, if we want to prove not a pushable lane, the approach we followed that we already illustrated earlier. So we start with not a pushable, which is pushable, to complement the thing which you want to prove. So not of X is X, so that is pushable, and we try to resolve this to nil. Then we resolve it to nil using existing rules and facts. There are several resolution techniques. As I told, this resolution process is not decidable. Okay, but there are several heuristics to perform that. Okay, BFS, DFS, breadth first search, depth first search, set of support strategy, etc. Though in general the problem is undecidable and may not terminate. Okay, so the problem described previously comes from the block solved problem in robotics. Okay, and more rules slow down the reasoning process, increasing the branching factor. Okay, so many expert systems retain only those rules with high utility. Okay, so basic structure of expert systems. So we have an expert from which we have the knowledge acquisition subsystem, and this is further taken to knowledge-based facts and heuristics. And we have the user who interacts with the user interface, which in turn interacts with the explanation subsystem, which in turn interacts with the inference engine. The inference engine interacts with the knowledge engineer and the knowledge-based facts and heuristics. Okay, so this is the basic structure of an expert systems. Okay, so the rule-based expert systems. In rule-based expert systems, we have E, the evidence. Okay, H, the hypothesis. Okay, and rule is evidence implying hypothesis. Okay, and if you have PH, sort of, if you have the idea of Bayes theorem, you can derive this thing. This is conditional probability. PH given E, hypothesis given the evidence is, say, PAB is basically PAB is PA times PA given B, or PB times P given A. You are using this relation in this, deriving this equation. The hypothesis given evidence is PE given H multiplied by PH divided by E. Okay, and similarly PH prime given is PE given H prime multiplied by PH prime divided by PE. Okay, dividing 1 by 2. Okay, we have the posterior odds. Okay, so OH given E, that is posterior odd, is PH by E divided by PH prime given E, and which is nothing but PH by E divided by 1 minus PH given E, which is PE by H multiplied by PH divided by PE by H prime multiplied by PH prime. Okay, so if we continue, and we have discussed what is posterior odds, and prior odds are OH, which is pH by pH prime, or a complement, whatever, okay, which is pH divided by 1 minus pH. Then the likelihood ratio is lambda, which is P E given H divided by P E given H complement, okay, and you can derive this odd posterior odd OH given hypothesis given evidence is lambda times OH, okay. So the value of lambda is provided by the human experts or can be derived statistically, okay. These are some results that are used in typical expert systems, rule-based expert systems, okay. Notion of posterior odds and prior odds, okay. So rule learning, at present day, we may apply these in data mining, where we mine association rules based on certain measures like support and confidence, okay. So this, so as I told, these are typically applied in some market basket data where we have a set of transactions, okay, on the item sets, okay. Let the set of all items be denoted by I is equal to I1, I2 up to IM, okay. Let the database of transactions be denoted by DB, which is T1, T2, Tn, where each Ti is a subset of I, okay. So which comprise of some items belonging to the set I. So I1, I2, I2, such that Ij belongs to I, okay. And this any subset X of I is called item set, okay. And this is, and the association rule is an implication of the form X implying I, okay, where X and I are subsets of I, okay, and X intersection Y is equal to phi, okay. So X is called the antecedent and Y is called the consequent of the rule, okay. So we have to derive these association rules, okay, and we have two notions associated with the association rule. We have one is called support, the other is called confidence. So the support of an association rule X implying I is the percentage of transactions in the database that contain X union Y, okay, and the support of an item set X, which is a subset of I, is the percentage of transactions Ti in the database, okay, such that Ti is a superset of X, okay. So all if I have if I collect all those transactions that are superset of X, I can easily compute the support of the item set X. And similarly with the association rule, I have a notion called confidence. Okay, the confidence of an association rule, okay, is the ratio of the number of transactions that contain X union Y to the number of transactions that contain X. So thus the value of this confidence value lies between 0 and 1. And in other words, confidence X implying Y is nothing but support X Y divided by support of X. Okay, and this support you can easily compute using a very efficient algorithm called a priori algorithm, which tries to prune, means which tries to build up a lattice of item sets, okay, based on this subset relationship, okay. So in data mining, our goal is to extract association rules with high support and confidence, okay. So this is the typical goal of the data mining, and some expert system examples. We have Dendral, the system which is capable of the structure of chemical compounds, giving a specification of compounds, constituent elements, and mass spectrometry data obtained from samples of the compound. Okay, Mycene, which is an expert system that diagnoses infectious blood diseases and recommends list of therapies for the breast patient. Okay. And next, it learns heuristic rules for the solution of symbolic integration problems. You can perform definite integration very easily on computer numerically by using things like Simpson's rule, trapezoidal rule, Wedel's rule, and so on. But for symbolic integration, okay, you have to do little bit. You have to approach in a little bit different way. Next is one such expert system which uses heuristic rules for the solution of symbolic integration problems. Okay. Another interesting problem in the context of artificial intelligence is the problem of natural language processing. Okay, so so you learn a language by learning its structure and not by memorizing all sentences in the language. So natural language processing is a very difficult problem. Okay, it's not like formal languages which we use in computers. Okay, so therefore, useful model of language is the one that characterizes the permissible structure through grammars. But unfortunately, for most of the natural languages, we don't have formal grammars. So we have grammars, but we don't have formal grammars that computers can very easily parse. Okay, so we have formal grammars for usual programming languages. Okay, like Pascal, C. Every programming language has a grammar. Okay, actually, usually it is deterministic context-free language for which you can easily parse. Okay, so yeah, so but natural language there is no formal grammar. Okay, so several techniques have been proposed to handle this problem. Okay, so one is case grammar, in which you have called phrase structured grammar. Okay. You have systematic grammar with clauses, okay, semantic grammar with attributes added, okay. Then you have recursive transition networks, which is RTN, okay. You have augmented transition networks, which does even something additional to this recursive transition networks, which was very popular in natural language processing. Okay, specialized formal grammars may be obtained in restricted domains. Actually, this natural language processing problem we don't try to solve in a very general domain. It's a very huge problem. So people try to concentrate on a very restricted domain, okay, and try to solve this problem of natural language processing, where perhaps we can design some sort of formal grammars, okay, in these restricted domains, okay, so that can aid us in the process of parsing. Okay, so I would conclude. Okay, artificial intelligence and learning techniques not only helps in computer implementations to get refined progressively, but also can help human experts to have a better insight into many real-world problems that are difficult to formulate objectively. Okay, so that's why this artificial intelligence field became popular, because in the field related to computer science, in which these formal languages and this subsequently this complexity algorithms, all those things, there we try to deal with problems which are very precisely defined, which may not be real world problems. Okay, so in practical problems which we want to solve, okay, we have to employ this type of heuristic functions, because and also many such problems, even these people have found out to be intractable, or maybe many problems in which we don't have wouldn't prove to be intractable, we don't have good solutions, means efficient solutions. So for these problems, we try to go for approximation methods and all. Okay, maybe we try to these approximation techniques try to bound the approximation factor, okay, to a good extent. Maybe, but for practical applications, maybe we may be interested. We may not get such good bounds on this approximation factor in many cases, but on most of the runs, with these interesting heuristics applying, in most of the runs, it would give a reasonable solution to many such practical problems. That's why the field of AI came into existence, and it's a useful topic, okay, and it's very popular nowadays. Okay, so I would like to conclude with this my talk. Okay, so the references are that I used basically Artificial Intelligence, a New Synthesis by Niels Nielsen, which is from Morgan Cochrane, Artificial Intelligence by Elaine Rich, Kevin Knight, and Shiv Shankar Nair. Okay, he's one of the faculty member in our department, Professor S.B. Nair. Okay, and I have used another book, Artificial Intelligence and Expert Systems by Patterson, which is from Prentice Hall. Okay, so these are the references that I mostly use for the purpose of the talk. Okay, and some so that's it. Okay, thank you for listening. So if you have any questions, you can now ask me related to this. Okay. So
Thank you, sir. If you can unshare your screen, sir, so that we can see you and we can have the questions posed by students. Most of the students are very keen that if we have final year project at IIT Guwahati.
yes.
Yes, sir. Sir, the question is that if we have any opportunity for final year project at IIT Guwahati. Sir, can you hear me?
Excuse me, I'm not. Actually, the voice is not very clear.
Sir, is it clear now?
Yeah, it is now. It is clear. Yeah.
Yeah. Sir, most of the questions I've asked is that if there is any opportunity or scope of having final year project at IIT Guwahati.
I means you mean to say a project under my supervision?
Yes, sir. Because they have, last semester as a internship and as projects, to be
Yeah,
taken as
yeah. I usually earlier used to conduct certain internship actually because I am the training. I mean, and this internship coordinator. I am right now also, but now it is due to this pandemic. This has stopped for the last 2 years. Okay, earlier it used to happen this internship program in the summer. Okay, so
Right.
that time I used to take several interns and. I used to allocate to different faculty members in our department, but now our students means even in our campus, our students are not there. So and also this internship program is not being conducted for the last 2 years. Because this hostel accommodation and all those things has to be done. Okay, and this from the hostel I didn't get permission. And now they are not giving permission in the hostel. So that's why there are some difficulties for this internship program, but I don't know what will happen in the next year. Okay. So let's hope for the best. Okay. So as per so that's the situation. Okay.
Thank you, sir. And the question here is by Abhishek Shah of 7th semester. He says, as AI is concerned about putting human intelligence simulations by machines. So if there is a human intelligence involved, there must be pros and cons also. So the question, yeah.
There are always certain capabilities of machines as I told in many cases the human interventions would perform much better. Okay, so but as I told, this type of techniques are used to solve many practical problems. Okay, for which we would expect reasonably good solutions. Okay, with these techniques may not be the exact solution or may not be very efficient solution. Okay, reasonably good solutions. These techniques are applied keeping in mind the practical nature of the problems. Okay.
Right. So that is why the question is extended as the question is how can a machine with human intelligence can solve the cons by itself? Is it possible today or in future?
Again, I'm not getting the voice,
Well, sir, now is it okay?
Yeah, now it is okay. Yeah.
Okay. The question is then, in that case, how a machine with human intelligence can solve the cons by itself? Is it possible today or in future?
Machine with human intelligence will solve.
Yes. Ha,
Can
especially
you
the
please
cons,
repeat?
because it is pros and cons both together involved in that. So how the cons will be resolved?
Again, got stuck.
Okay. Maybe, sir, the net is interfering in between. I'll take up the second question, sir. Is it audible now?
Yeah, yeah, partially audible. Yeah.
Sumit, sir, if you can take up the question.
Yeah, you can tell the
Okay, ma'am.
question. Yeah.
So second question. Can you hear me, sir?
No, you are not also audible. You are also not audible. Very good. Your voice is not clear.
Okay, sir, am I audible?
Yes, I can listen. Yeah.
Yeah. So, Namrata ma'am, which question? That is question 2 by the Abhishek.
Yes.
Yeah, okay. So what he asked that and it will make the humans more lazy and dependable, and maybe the rate of unemployment would also increase. So what will be its outcome in future?
Not means not getting the voice really means sound
Uh,
is
Dr. Mitra, can you hear me now
now I
clearly?
can hear. Now I can hear.
Yeah. The question is that if this artificial intelligence will make humans lazy and unemployed.
Oh, okay. No, means it. I don't think so because it will create these type of applications. Artificial intelligence applications will create the necessity of human experts in this type of fields. Okay, so that will create the job opportunity in that domain. Okay, and so I don't think it will lead to the problem of unemployment in that sense, because human experts will be required to solve the problems in that domain, and that will cater in the development of new jobs in that type of problems, in those type of related problems. Okay.
Thank you, sir. I hope it has been answered to Abhishek. And now it's time to wrap up with concluding remarks and vote of thanks. For that, I invite Dr. Sumit Chaudhary, Head of the Computer Science and Engineering Department in the Rashid University. Over to you, Sumit, sir.
Thank you, ma'am. Thank you very much. So good afternoon, everyone. Myself, Dr. Smith Chaudhary, Head of Department, Computer Science and Engineering at Rashid University. And it is my privilege to propose a vote of thanks for today's webinar. First of all, on behalf of Indrashil University, I would like to convey my sincere thanks to Dr. Pinaki Mitra, who is Associate Professor at IIT Guwahati, for enlightening us with his knowledge and the domain of artificial intelligence and machine learning. Especially today's webinar was full of knowledge and interesting facts. It gave deep insight into that topic, and I'm pretty sure the precious knowledge given by you, sir, will definitely help our student and participant in future. Once again, I would like to thank Dr. Pinaki Mitra for taking out time from his busy schedule and enlightening us with the knowledge aligned with the topic of the webinar. Thank you so much, sir. And especially you have covered different topics of AI and ML, like supervised learning, unsupervised learning, and the algorithm that exists in different types of machine learning that you have covered also. And like you said, These times, like IIT Guwahati is not permitting for internship, but in future, definitely our student and we all also will keep in touch with you and definitely will visit IIT Guwahati with your consent only. At last, I would like to convey my sincere thanks to Provost Indrashil University, Dr. G.S. Yadav sir, Dean School of Engineering, Dr. Amishra sir, Dean School of Science, Dr. Bharti Devi ma'am, Dr. Namrata ma'am, all panelists, faculty member and participants. Thank you very much. Thank you all the participants to attend and take the knowledge from this webinar. Thank you everyone. Over to you, Namrata
Thank you,
ma'am.
Sumit sir.
Thank you.
Thank you, Sumit sir. And Dr. Mitra, we wish you health and safety, sir. Have a
Thank
nice
you.
day.
Thank you.
Bhin.
Thank you. So we can leave now?
Thank you, sir.
Okay.
Yes, sir. Thank you.
Yes,
Thank you
sir.
very
Thank
much, sir,
you
for
So much,
joining.
sir.
Thank you, Professor B.S.